In this video, we're going to take notes on the inverse operations, and I'm going to practice with you what I expect when you're taking notes, since I will be taking grades for different note pages. First, I told you that I want you to title it inverse operations, so I need you to title it the same thing that I title it. As you can see, it's really hard for me to write with this scribble tool, so instead of writing with that, I think that'll be painful for you to watch. I'm just going to go ahead and type so that I can try to keep a good pace. So remember, I will want you to write your first and last name. I'm going to need to change the thickness so you can actually see this. Okay, so first and last name. And then down here, you're going to put the block that I teach you, which you can just put B1 or B2 or B3. So I'll keep that shorter. And then you need to put in the top right-hand corner the page number. So the page number for this set of notes is page 3. So I'm going to put a 3 up here in the corner. So you have your page number. If you want to put a P for page number, that's fine, or PG3, however you want to do it. Your first and last name, and then your block. We have the title, so we're ready to go. Now, I want to use Cornell notes. So what I'm going to do today is draw a line, and I'm going to put a line right here. And you can do the same. With Cornell notes, I don't know if you've used Cornell notes before, but you put either a question or like the vocabulary term on this side, and then you take some notes on this side. So I'm going to set my notes up this way for today. All right, so let's start with, I'm going to go back to the scribble just for the first part. So when we talk about inverse operations, the word inverse means opposite. Okay, actually I need to type that. Okay, so inverse means opposite. Okay, with inverse operations, you're undoing the original operation. So write the word opposite, and then from here, I do need to go back to the scribble, and I want you to write out your opposites. So the opposite of multiplication is division. The opposite of division is multiplication. The inverse of addition, or the opposite of addition, is subtraction. The opposite of subtraction is addition. Now, this should be reviewed from 6th grade, so we're just trying to help you to recall what you learned in 6th grade. Now I'm going to go ahead and write out our first example that we're going to use. So this is where I'll really make use of the Cornell notes. So my first example looks like this. It says 3x equals, we'll start with 27. Now a lot of you could say, all right, 3 times what gives you 27, and you could come up with what x equals. That way of thinking is considered like 5th grade reasoning, 6th grade reasoning. You might have even used that reasoning before 5th grade. In 7th grade, you are expected to be able to use inverse operations to solve an equation. They don't just want you to be able to think about, I think I can come up with what x equals. They want you to show how you solved the equation, how you isolated x or got x alone. So we're going to record that problem one more time. 3x equals 27. And then we're going to ask ourselves a series of questions. I'm just going to ask it out loud. You don't have to write these down. But the first question is, what side is the variable on? So when we're solving, you want to think about there being a left side and a right side of the equal sign. So we have an equal sign in between. There's a left side and a right side. In this example, the variable is on the left side. Now the whole point is to get that variable x alone on the left side. You want it isolated. When it's alone, we know that it's isolated when it says 1x. And remember that 1x is just the same as x. But that's how you know that x is isolated, is when the coefficient is 1. So I'm going to look at this and I have to figure out the original operation. So that's my next question. What is the original operation? And I'm going to change colors to show you that when you don't see anything between the number and the variable, that means that 3 is a coefficient of x, or you could say 3 is being multiplied by x. So when you don't see an operation between, that means that the operation is multiplication. So the original operation is multiplication. So let's go back up here to our inverse operations. The inverse of multiplication is division. So to solve this problem, what we're going to do is we're going to divide. And we're actually going to divide each side by, should it be divide by 3 or should it be divide by 27? So let me answer that question. You should divide by 3. You should divide by the number that is in front of the x, the number that is the coefficient of x, because you're trying to get rid of it. And whatever you do to the left side, you have to do to the right side to keep the equation equal. Now let me show you what happens, and I want you to draw this on your paper too. 3 divided by 3 is equal to 1. So what we're going to do is we're going to draw a 1 through that 3 divided by 3. And we are left with 1x. So that 3 divided by 3 becomes 1. I bring down the equal sign. Then 27 divided by 3 is 9. 1x is the same thing as x. So there's my final answer, x equals 9. All right, let's continue. Next problem. All right, the next problem, let me go back to my original color. Okay, so the next problem is x divided by 2 is equal to 15. Now once again, you might be able to do this in your head, but the point of your 7th grade year is to be able to show your work and solve the equation using inverse operations. So I'm going to recopy that over here on the right because I want to be able to see that original equation. You see how it kind of gets messy over here, but I can still go back to the original equation when I use Cornell notes. So x divided by 2 equals 15. All right, so what I'm going to do is I'm going to take a new color and I'm going to go through the questions. So the first question I'm going to ask is, what side is the variable on? So I'm going to split it into the left and right side, and I'm going to recognize that the variable is on the left side again. So I'm going to put an L. It's on the left side of the equal sign. Next, what is the original operation? Okay, so you look in between the variable and the number, and I see that the original operation is a fraction bar, so that's division. And the opposite of division, let's look up here, the opposite of division is multiplication. So to solve this one, we're going to use multiplication. So on the right side, it's easy. I show multiplication like this. Oh, and I forgot to address that. We're multiplying by 2 because you're always multiplying or dividing by the number that's keeping the variable from being alone. So that's why we're multiplying by 2. Now, on this side, I also am multiplying by 2, but since I'm multiplying by a fraction, I'm going to put 2 over 1. I'm going to write 2 as a fraction. Then what happens here, when you multiply across, remember with multiplying fractions, you multiply across, and I get 2x in the numerator, and I get 2 in the denominator. I bring down the equal sign. 15 multiplied by 2 is 30. Now, by multiplying by 2, what happened is, do you see that I have 2 divided by 2? Well, 2 divided by 2 is equal to 1. Anything over itself is 1. So negative 5 divided by negative 5 equals 1. 3 over 3 equals 1. 8 over 8 equals 1. So this 2 over 2 is equal to 1. So what I'm going to do is I'm going to go over here And I'm going to actually draw a 1 through that, because 2 divided by 2 equals 1. And I'm left with 1x equals 30. All right? So that's the same thing as x equals 30. All right, now I need to go to a new page. So I'm going to do the same thing I did on the other page. I'm still continuing this same set of notes, inverse operations. So it should still be titled inverse operations. And I'm going to type that because that's going to take forever for me to write. So inverse operations, you're still going to put your first and last name and then your block. And then we can continue our notes. We have 2 more examples to record. All right, so let's go back to Scribble. And the next problem is x plus 4 equals 7. And I forgot I didn't draw my line. Oops. That's under where the scribble part is. So I draw my line. And then I rewrite the problem, and then I'm going to solve it. So the first thing I'm going to ask myself is, what side is the variable on? And the variable's on the left side of the equal sign. So the whole point is, you want to get x alone. This 4 is keeping x from being isolated, from x being on its own, so we need to get rid of the 4. Then we ask ourselves, what is the original operation? And the original operation is addition. So to solve this, we need to undo the addition. So we look over here, and the opposite of addition is subtraction. So to solve this problem, we're going to use subtraction. And we're actually, since we're trying to get rid of the 4, we're going to subtract 4 from each side. Now let me show you how we're getting rid of the 4. Well, positive 4 minus 4 is equal to 0. I am trying to draw what looks like a 0 right now around the positive 4 and the negative 4. That is called a 0 pair. A 0 pair equals 0, and it's gone. If you want to, you could write x plus 0, but that's kind of a waste of your time. You're allowed to just write x instead. And then over here, 7 minus 4 is equal to 3. We've solved this equation. And we have one more left. All right, x minus 11 equals 18. So we rewrite the problem over here on the right side. X minus 11 equals 18. All right, so the first thing we do is we ask ourselves, what side is the variable on? All right, the variable's on the left side. So we're trying to get this subtraction of 11, we want that to disappear because we want x to be alone on the left side. Now we ask ourselves, what is the original operation? So look between the x and the 11, you see subtraction. So the original operation is subtraction. So look back at our inverse operations. The opposite of subtraction is addition. So to solve this, we're going to add 11 to both sides. The reason why we add 11 is because the 11 is what we're trying to get rid of. So if we add 11, take a look at what happens. This is a 0 pair. If you are in the whole 11 and then you add 11, that will bring you to 0. So this will disappear and we'll be left with just x, because x plus 0 is just x. And then on the other side, we're going to add 18 and 11, and we get 29. So x is equal to 29. Now the coefficient of x was 1, so that's what I was saying at the beginning about we know that it's solved when the coefficient of x is 1. So x is equal to 29. Oh, and you can't have any other number on, like you can't have the 11 on the left side. X has to be alone on this left side. So we just did a few examples and we finished our page 3 notes titled Inverse Operations.